Caddis Maximus here, this time doing a quick review and comparison of various 7 1/4 inch circular saw blades. 7 1/4 inch circular saw blades would be the most common size of circular saw blade. Whenever you're using a saw to cut wood or other materials, it's most likely a 7 1/4 inch saw. Cordless saws tend to be smaller, 5 and 6.5 inches. But now they're getting powerful enough to where they're also 7 1/4 inch standard. There's also other standard sizes, 8 1/4 inch, 10 inch, 12 inch, etc. 10 inch is about as large as you can find in a handheld or portable circular saw, although they have made 12 inches in the past, particularly skill saw with the model 127. I have one, I've never reviewed it, I need to restore it, but they're kind of dangerous. One thing to note is the price of saw blades, when they get small, they're still around, it's only $1 or $2 difference between a 7 1/4 inch and say a 5 inch or even a 4.5 inch. That would be used in a trim saw. But when you start jumping to maybe from the 8 1/4 inch size up to 10 inch and 12 inch, then there's some pretty big price jumps. A big point of me doing this video, I'm going to continue to do tool reviews as I run into these. Digging into, I believe, pliers is the next thing I'm going to get into. But I wanted to not just really do like a saw-off or a comparison of how heavy-duty these blades are, because those kind of tests I do find are pretty empirical. Really, if you search around YouTube, I found videos and they're, these Milwaukee product demonstrations. They engineer these elaborate test rigs with pneumatic and spring-loaded slide systems, so they can mount different saws and the same saws with different blades and then quote-unquote apply the same force to see how fast they go. That's really hard to kind of capture on the review. Otherwise, I'm just cutting off pieces of material with a circular saw. This is more just to compare what would be considered some of the best, like these Freud Diablos, some more common brands such as Irwin and DeWalt blades, some more specialty blades such as this Hardy plank blade or a cement fiberboard blade. There are demolition blades here. That's one thing you'll start to notice is there's a variety of different blades. There's a variety of different properties. There are blades such as this Masashita, which is an aluminum cutting blade, and it has a special tooth design. We're also going to compare tooth designs of what makes a more heavier duty blade where the teeth really stay in versus a lighter duty blade. We'll compare slightly older blades that are much thicker, known as the kerf, or how thick the blade is and why you might want some of the older style blades, as well as looking at properties of what is a quality blade that you would want to save and, for instance, get resharpened versus other blades such as these Diablos, which use a very high quality carbide, but they do use small pieces. My experience is that you end up knocking out teeth. The teeth inevitably, get knocked out, and there's not a whole lot worth resharpening, even if it only costs a couple $3. That changes with higher quality blades, and as you go into larger blades such as 10 inch and 12 inch, which are used in chop saws and table saws, those blades start, approaching 30, 40, 50, even 100 or more, depending on if you want to get an industrial grade blade. But they also tend to have much thicker teeth and are actually designed to pay themselves off by having the ability to spend $10 and get them resharpened several times. And also having teeth that are better locked into the blade body so that they're less likely to actually get knocked out. And I guess it's a bit late to say let's get right into this, but let's go ahead and get right into this. We'll take a look at these two skill saw blades. These are just a basic pair of skill saw blades. A lot of times these are the type of blades that would come with a skill saw, or the grade of blade that would come with almost any saw. Although I'll have to say that some of the circular saws like Milwaukee's and etc. are coming with better blades rather than really cheesy ones. And what kind of makes these cheesy is they do have a pretty thick blade body, but it's not for... And it does help with structural rigidity, but it's just more because when you get a real thin blade body, then it has to be made out of higher grade steels that are hardened better, and you have to have better cutouts for the expansion slots. And that's the first thing. All those cuts that are in these saw blades is because when they get hot, they're a big piece of sheet metal, and then they'll start to warp. And so you cut these slots, and so as the outer edge expands, it has some place to go so that the blade doesn't get all warped and start wobbling around badly when you start using it hard and it starts getting heated up. And these are just basic blades, so even though they have a thick body, if we zoom in a little bit here on the teeth, the property of the teeth is that they just have a notch how the pieces you can't weld carbide to steel. That doesn't work, so it's brazed. It's not solder, it's bronzed or a special type of compound, and it's quote unquote gluing the piece of carbide to the blade. And so on lower quality blades, or less pricey blades, the carbide is just set into, there's just a little notch that's stamped out when they stamp the blade, and then they braze just a little piece of carbide in there. There's nothing really supporting it. What ends up happening is you hit a nail or something, and since nothing's supporting it, either the end of the tooth breaks off, but a lot of times it just pries the whole piece of carbide right out of the blade, and then you notice sometime that one of these metal teeth just doesn't have a piece of carbide in it anymore, and there's just nothing capturing it. And the same thing would be true for this 40 tooth. It's actually even less brazing on this one. Finer teeth mean a smoother cut. You cannot cut as quickly, but it does make a nicer cut. And with a high quality saw, the cutting speed isn't that big of a difference. However, they are more expensive. You're paying more money for more teeth. That's why what are known as framing or general use blades end up being between 18 teeth and 24 teeth, because that's a balance of having enough teeth to where it's not too aggressive, but also allows a cost-effective blade. Now, moving on, we'll talk about this Matsushita. This is an aluminum cutting blade. There are also blades that are designed for cutting steel. Freud Diablo has ones that are known as steel demons, and that's one interesting thing about circular saws. And if you're using something like a worm drive skill saw, you can really get away with that. And it's a concept a lot of people aren't aware of, is using something like a skill saw. And I keep talking about skill saws. Skill saws, as opposed to, say, sidewinder saws, are the saws that have the motor going in a straight, and then they have a worm gearbox that transfers the power 90 degrees. So when I talk about skill saws, I actually mean genuine skill saws like one of these, versus just any type of circular saw. The name of this saw is commonly used to refer to any circular saw, but when you're running heavy duty blades or cutting non-ferrous or metals like steel and aluminum, you tend to want a heavier duty saw, so an actual skill saw. So this is a blade that's specifically designed for cutting aluminum, and it can be great when you're cutting things like aluminum plate, diamond plate, that kind of stuff. You can get nice straight cuts, and you can go very fast using any kind of grinding wheel or anything like that, and that's a big advantage of circular saws. And I'm going to zoom in. If you ever see a blade where you can't really read it, but you're curious if it's designed more for wood cutting or for metal cutting, there's a real special pattern to the teeth on metal cutting blades. And how it works is blades are labeled like ATB, standing for alternate tooth bevel, which is a tooth, as we can see here, this tooth would cut on this side, and then we have a tooth where the corners have been deliberately ground off, so you would have a shaving on one side, and then it would shave in the middle, and then this tooth would shave on the other side. So it's actually using a set of 3 teeth to go make this essentially the entire cut. So it's cutting one part, the center, and then the other side to reduce the load and to make the teeth much more durable. And even on this blade, we can start to see some of the difference versus the skill. It's pretty subtle, but versus just a shelf that the carbide teeth sit in, we can see that they have like a little notch, and the back of the piece of carbide is rounded. So when they braze it, the back of it kind of sits in that notch, and it provides a hook. So when the piece of carbide, if you hit, when you're cutting metal, it's much heavier duty. It prevents it from wanting to get pried on the front of the tooth and lifting it and causing it just to fall out, like might happen with those cheaper skill saw blades. And so that's one aspect to look for. And if you see one of these weird blades where it looks like it has a bunch of damaged teeth, where they're alternating with ones that have no corners to ones that have corners, that's actually a metal cutting type of blade. And then you also know because the teeth are better locked into the blade body. Now we have a couple great example of what I mean by having very well locked in teeth. This blade, I'm not exactly sure who made this blade here, and it's actually pretty rough on that side. Here we go. This, and let's zoom in again, you can see that those teeth are held in really, really well. This, I believe, is a blade that's designed for nail cutting or demolition work, and one of the ways you can tell that is now the teeth, they don't just have a little rounded section where they kind of sit in a little notch. This is a big square notch. You can see that there's a big piece of steel that actually comes up over the top of the tooth. The tooth sits in very deeply, and then it has another subtle shape difference with this little lobe on the bottom which locks it so it can't pry up and it can't pull out. And so when you see, and that's what caught my eye about this blade, is I looked at it and I saw those teeth and I thought, they don't insert teeth. So this is the kind of blade where the teeth basically will never completely fall out of this blade body. The worst that would happen is the teeth would actually chip or break off. But that's how you tell a very heavy duty blade from something that's a bit lighter duty. A lot of these diamond shapes, that skill saw that I showed earlier, that's how they drive blades. They use a more positive drive action rather than just having two washers that use pure friction through a round hole in the center of the blade. They use what's known as a diamond drive. Now 7 1/4 inch skill saws, like the one I showed you, still have a kind of a clutch type system where you can adjust how tight the bolt is. But when the spindle's actually driving the blade, they use a diamond drive for more positive engagement. And to tell you the truth, since they kind of use a clutch system now anyway, meaning that the piece that the blade sits on, the diamond, isn't splined anymore. They still kind of use it traditionally, but you'll only really see that on the worm drive saw. So on a vintage blade, how you really know is they have a thick body. A lot of older blades were thick bodied, and you can tell a high quality blade, and this is why I have this old one out, is not only is it just a nice thick body, but you can see how large the pieces of carbide are. If we start comparing to any of these blades here, let's say one of these DeWalts, which is a respectable blade. Whoop. There we go. You can see that the DeWalt, the pieces of carbide in the DeWalt here are like microscopic compared to what would be, I would consider a more commercial use blade. And so that's one way to tell. An additional way to tell a high quality blade is not just a thick body, but when you see really thick, oversized teeth like that, that means that there's lots of extra material to get resharpened. So this is a blade, and in my area, it only costs like $3 to resharpen one of these. And this is a blade that you could get away with multiple resharpening, say 5 or 6 of them. Now, talking about how the thickness of blade bodies and the thickness of teeth to be resharpened, just as a quick example, here's a 10-inch 80-tooth Diablo blade. This retails for $50 on the shelf, so it's a pretty expensive blade. So when you start getting into these larger blades, just inherently they start to be being made out of thicker bodies. This 10-inch blade maybe has about the same thickness as this heavy-duty 7 1/4 inch blade, but you can see that proportionately that these pieces of carbide are huge. So they do intend for these blades to be resharpened multiple times. This would be one that's a much heavier duty blade. This is about 30% thicker than that Diablo, and you can hear it. Really nice. And this would be closer to a more industrial grade blade. And this is also a non-ferrous cutting blade. Somebody had used it for cutting some type of wood material, but I knew what it was when I saw it because I saw the tooth design where it has these, every other tooth is beveled, evidencing that it's made for heavy duty materials. Anyway, we'll get into some other blades, such as these polycrystalline diamonds. So these are diamond blades for cutting cement fiberboard. So in the last couple of decades, it's really started to get popular. This, what's known as hardy board or hardy plank as a brand name, but it's a cementitious, I believe, fiberglass reinforced. It's used for siding. It's waterproof and fire resistant. They use it in bathrooms. When you refinish bathrooms, you tile over it. But it's incredibly abrasive and difficult to cut. So what they've come out with is these industrial diamond tip blades. I've used the Diablo ones, but they're 4 teeth. And by the time I was done, 2 of the 4 teeth had fallen off. The DeWalt is a 6 tooth, and I kind of like that a little better because there is more teeth. But and even though they're diamond, they're not 100% diamond teeth. And I wanted to show that here. They kind of get you. If you can look closely, there's a little black layer on top of what looks like a carbide tooth. And that little black layer is the diamond. And then it's, you know, it's glued, basically glued or sintered to a piece of carbide, which is thus glued or sintered to the steel blade body. And that's how these teeth work. They're very small, little square teeth. And the issue is because they're so small, they're just, and they have no capturing, nothing to really lock it into the blade body, that inevitably, you know, you hit something, who knows what, and it just knocks that little tooth out. But just to show you, that's what these kind of odd blades right here is. They're designed, they have this curve to really limit how much of a bite the tooth takes, and it takes a little scrape, and then it has these little ridges to help clear out the material. And we do have a few different DeWalts here. DeWalt has some nail cutting ones, and what I kind of find interesting is that their nail cutting ones look exactly the same. They have like the same size teeth and everything, so I'm not exactly sure what makes the nail cutting blade any different from their standard construction blade. But this is just an example of where they sell, you know, particularly demolition rated blades. And DeWalt has never, with this kind of their accessories, they kind of do switch up over the years. And what I find interesting is this is great evidence. This is an older 18-tooth blade. This is a slightly newer 24-tooth blade, and you can see that they put the printing on the different sides of the blades. I should, actually I'll point that out in a second. And then of course, really modern blades are like this, where they have a full coating over the entire surface of the blade. This is really what's been popular recently, especially with the Diablos, and it makes a lot of sense. These coatings do tend to hold up, in my experience, a lot better than I expected. Not perfectly. If you hit against the side of a nail, it'll scrape it off. But they do. I mean, the saw seems to run cooler, the blade runs cooler, it doesn't want to bind up in the cuts as much. And then modern blades, as we can see here, are much thinner. This is a pretty flexible blade, but it isn't taking a very big bite, so it really goes through the wood nicely. And you have less issues with not compensating for a wide curve, such as this blade. This blade's almost, with the teeth, twice as thick as this DeWalt. If we can get it to focus, come on. There we go. Come on. Yeah, much thicker. And so that would actually, if you're really precise with your cuts, that could become an issue. And so that was just an example of various DeWalt blades and how they've come along. One thing I did want to point out is all these circular saw blades have the capability of being a diamond drive, because skill saw and their worm drive saws have been around for almost 100 years. So it's integrated. They all have, small ones, all have diamond knockouts. That's not true with 10 and especially 12-inch blades. But when you're in the 8 1/4 inch and all those other sizes, and that's what it is. Whenever you see a blade, you always wonder what that weird little piece is. That's not for heat expansion. That's so that you can knock this out and then have a diamond in it to mount onto a traditional skill saw like I showed earlier. The one thing to really pay attention to is that most of these are actually designed to be knocked out. You would just put this blade between a couple pieces of wood and then just use like a little a nail and a hammer, and you just tap around the inner ring and it just jams it out. This isn't welded in there. It's like a press fit, so it works really well for aligning the blade on a sidewinder saw where it just uses a circular hole. And all you have to do is tap it. Sometimes it takes a couple of hard taps, and then this will just drop right out. But that tends to be the system for most blades. The DeWalts, those skill saw blades, these Irwins, that's how it all works. You just find an area, you put it between a couple pieces of wood, and you just hammer that out. But that isn't 100% true. And let's go ahead and get into these Freud Diablos. These are known as some of the best blades out there. Skill has, and one of the reasons was this titanium cobalt carbide. That grade of material, if you look it up on Wikipedia and around Google, is a super duper, I wouldn't say alien technology, but it's an incredible material. It is a very durable form of carbide that can be upwards of, and people who are familiar with Rockwell hardness can be 20 Rockwell points harder than standard, say, C2 carbide that's used in, would be a cheap end mill or cheap saw blades. This is carbide that could cut other carbide. And it is known to be able to get as hard as 9.5 Mohs, so 95% the hardness of diamond, but it doesn't have the brittleness that diamond has. So it really is a super material, and it's one of the reasons Diablo blades and Freud, at least they're, the 7¼ inch blades, tend to have a bit smaller pieces of the carbide because it is an expensive carbide, and they're really trying to make these blades hit particular price points, which is literally $5, $10, and $20 retail. $5 for the 24 tooth, $10 for the 40 tooth, and $20 for the 60 tooth. And Freud is really known for really making these deep question marks. They have an additional gap on top, so they get really complex in their engineering of the expansion cooling vents. You can see they have these weird patterns, where DeWalt just, does these holes. But it's just these red blades, they really are nice. The Diablos are pretty much the go-to. Now, another aspect I forgot to mention about cheaper blades, and let's go ahead and go back to this skill saw blade here. Both of these are 40 tooth blades, but on a higher quality blade, what you'll see is that the tooth is just an angled piece of metal. You can see here they've done a couple things. One, they've carved it out so it has more space in this tooth area to get chips and particles out of the cut, where this actually has less area. The second thing is you can see this little back tooth, that little kick. That also helps when particles roll off the front of the edge of the tooth, that it kind of grabs and will help kick them out of the cut, resulting in a cleaner cut. And that's another aspect of high quality blades. And I forgot to mention, on these red Diablo blades, and you have to be careful as they show twist, and that's what it is. These are very hard steel body, and instead of having the press fit piece like on any of these other blades, such as this DeWalt, they have you twist it out. And the idea behind that is that when you're pounding or the little insert out, sometimes on some blades it can get pretty stuck, one. And two, sometimes people aren't perfect and they'll hit like on the inside of the edge of the blade. They'll dent the blade body, and then the blade might have potential to wobble or get bent. And so I thought that was intelligent here, where they design it, they use a laser cut, and it has two little like remaining pieces of metal that hold it in. And then you just put in a screwdriver and you just twist it. And since it's such hard steel, all you have to do is twist it over some, put the screwdriver in the other side, and as soon as you get it about 90 degrees, it just breaks and falls out. And since it's actually clean cut around most of the periphery here, you don't have to worry about damaging or bending the blade body. And so I do like the twist out. And it's also easier to deal with because you can just hold the blade in your hand and twist it out instead of having to find some place to actually hammer on it. So that really is a good idea. And then I had some 24 tooth blades back here just so you could see what they, different generations. They started out with gold plating, and then they went with their new white labeling, and then they really started advertising their Tyco. So that would be the three versions: is the gold plate, the white label, and then the Tyco white label. And you can see they've had issues with people, so now on these new ones, the do not knock out, twist out label has gotten much bigger and much more obvious on the new blades. So obviously they've had some complaints, and so labeling is their way of addressing that. I've talked about most of the points of saw blades, so we'll just go ahead and finish up with these Irwins. These Irwins are pretty cheap blades. They're not too bad. They've been working on their designs for a while, and I think if you go to a smaller hardware store, these Irwins tend to be like $5 for a 24 tooth, which is the same price as a Diablo at like a Home Depot, and I'd always recommend the Diablo over the Irwin. So I think Irwin blades are not that great for their price. They have these classic series, which are a heavier body. What I do find interesting is they don't have any relief at all, any kind of thermal expansion slots in their classic series, but that was, like $1. They do spend some time trying to improve the design, although it's a little different. You can see where this is an older 40 tooth, that's a newer 40 tooth, and they sacrifice some of the these little back teeth to make more space in front of the tooth, but still not as well engineered as Diablo. One of their big deals is this. They have figured out, quote unquote, some way of welding the carbide to the steel. And I suspect it's some kind of ultrasonic or friction-based system where they have some kind of machine that can press the piece of carbide against the steel and then wiggle it back and forth an extremely tiny amount. It would be far less than a fraction of an inch, but do so at extremely high amounts of force and frequency and actually get a friction weld happening. But that's the big deal, is when you see all these blades, they all have that little golden brazing material to glue the carbide to the blade. But somehow they figured out how to actually get it to weld. And the teeth, they seem to hold on okay so far, but I've only used one of these blades in some light cutting. To tell you the truth, I kind of worry because I think they may end up falling out quite easily, and I've read a few posts where people have had that issue. But the reason they do that is now they can get away with a microscopic piece of carbide. These blades have the smallest carbide tips I've ever seen, just literally a tip to take the highest amount of wear, right at the bleeding edge, and the rest of it's steel. And I find it amusing that they've managed to use this, figure out how to weld the carbide to the steel body without brazing it, saving money on the brazing, and saving money by making a much smaller piece of carbide, yet these blades are the same price. And the other issue is having such a microscopic piece of carbide. These are absolutely not intended to be resharpened. There just is like no extra material there for that to happen. And so I would recommend against the Irwin weld techs because they're just a little bit too much of a cash cow, especially because, with these design changes, they should be significantly cheaper. This 24-tooth blade should be $3, basically. If the Diablo is going to be $5, this should be $3 on the shelf. And it's usually not the case. This is priced to compete and be the same, and it's just not as good as a Diablo or one of those DeWalts. So anyway, that was the end of a long talk about circular saw blades, and really that way you have a bit more information. And generally, if you're going to want a reliable blade, just spend a bit of money. They're not that expensive, $5 or $10 to have one reliable blade, and then have a couple of cheap ones. And it's not super hard to change blades when you might be doing some kind of operation where you damage a nice blade. And usually you just spend the money and get a high tooth count finished blade out of an expensive brand, and then get 18 and roughing blades out of just whoever, because you're just going to beat them up anyway. And no, I don't have any of Harbor Freight's new generation blades, but they actually look like they're competitive, and yeah, their prices are okay. So at some point I'll do a review of those. Once again, thank you so much for watching. Please subscribe. Catus Maximus.